Hey everyone, today let's go through another LeetCode problem, 2670. Find the distinct difference array. Let's take a read at the problem first. You're given a zero-indexed array, nums of length n. The distinct difference, okay, let's take a look at the definition of distinct difference. Of array nums is an array diff of length n, such that diff I is equal to the number of distinct elements in the suffix, from I plus 1 all the way to n minus 1, subtracted from the number of distinct elements in the prefix, from 0 all the way up to I. Return the distinct difference array of nums. Okay, it's not super clear to me what the problem is really asking me to do, so let's take a look at the two examples. Example 1, 1, 2, 3, 4, 5, this is the given input array. Output is this. Let's see how the explanation goes for the output. For index I equals to 0, there is one element in the prefix, which is just 1, and 4 distinct elements in the suffix. 2, 3, 4, 5, all of these 4 numbers are distinct from each other, so total 4 distinct elements. 1 minus 4 equals minus 3. Okay, so that is how we get minus 3. Now I got it, what the problem is asking us to do. So basically, we would like to know the total number of distinct elements in the prefix and in the suffix, and then we want to do some subtraction. Put the difference into the result as the result array and return. Let's take a look at the second example in which there are some duplicates to confirm our understanding. So the given input array is 3, 2, 3, 4, 2. So for index I equals to 0, which is this one, there's only one element and 3 distinct elements, because although there are 4 elements total in the suffix array, 2 and 2, they are duplicate. So total distinct elements is only 3. So that makes sense, right? Now we understand what the problem is asking us to do. The approach, the idea that came to me is that we can have a hash map. The key of the hash map, actually we need 2 hash maps. One is to help us keep track of all of the distinct elements in the prefix. The other hash map is to help us keep track of all of the distinct elements in the suffix array. The key of both of the hash map is going to be the distinct element, and the value of both hash map is going to be the frequency, just in case if there is multiple same elements in this suffix of prefix array, we'll just decrement the frequency by 1. And once the frequency becomes 0, we'll just remove that entry entirely. In such a design, we can just use the size of each hash map to know how many distinct elements in either suffix array or prefix array. Then, while we're iterating through this, we can just calculate the result array. I hope that makes sense. If that is the case, let's quickly put the idea into actual code. Okay, so first I need 2 hash maps. First I'll call it suffix hash map, and then I need a prefix. How we are going to go through this? So prefix first. Prefix, there's only one element, so we'll just put prefix put nums 0 as the first element, so frequency is 1. And then we build out the second hash map, which is the frequency for all of the suffix. For I equals 1, we'll start from 1 because the first element, we put it into the prefix hash map already. Length I plus plus. So here suffix put, what we'll put is nums I, and then we'll check if this one get or default. If this one exists in the suffix hash map already, if it doesn't exist, we'll use the default value of 0, and then we plus 1. So then we have this, we'll initialize a result array, which is int nums length return result. So now we'll go through this. I equals 1, Well, actually, I will start from 0. Nums length I plus plus. So how we'll calculate the difference, distinct difference array is we can use the size of the prefix, which means the number of distinct elements in the prefix, right? And then use that to minus the size of everything in the suffix. That means the distinct elements in the suffix. And after that, we'll update it because basically we have one pointer. We are going through one pointer. This pointer is I. We use this pointer to go through this entire array one more time. Okay, so let's put it that. Okay, so this is I and suffix size minus. No, actually it should be prefix size minus suffix size. And then we'll check if I plus 1 is still smaller than, because in the end we will get out of the boundary of the size of the array size. If this is still the case, we'll use next nums, since we'll refer to this one many times. So first we check the next element. It will increment. We'll basically put this next element into prefix if it doesn't exist, or if it does exist already, we'll just increment its frequency by 1. So what we'll do, prefix put next prefix get all default, next default is 0 plus 1. So that what this line of code does is it's going to increment the frequency of this next number in prefix hash map by 1, because we're moving the pointer. The pointer is I from left to right, and then for the suffix array we are basically removing or decrementing the frequency of next in the suffix array. So we'll check if suffix contains key next. If that is the case, well, what we can do is just we'll check it one more time here, suffix. And if suffix get next equals 1, in this case, what we're going to do is we'll just remove this. We'll remove this key, remove this entry entirely, right? Otherwise, we'll just decrement suffix put next suffix get next minus 1. All right, that's it. In the end, we can just return result, which we are already doing already. Now let me hit run to see if there is any compiler error. Accepted, hit submit. All right, accepted. So this is the entire solution or algorithm, how we implement it, basically using 2 hash maps to keep track of suffix and prefix. I'm sure there are more like concise ways to do this, but I think this is one way that is very straightforward in terms of thinking and to solve this problem. Time complexity of this problem is just O n. N is the size of the input array. We'll just go through this array. Although there are 2 for loops, they are not nested, so the time complexity is not going to be O(n) squared. Instead, it's just O(n). Space complexity is going to be O(n) as well. It's not constant, unfortunately, but it's not super bad. It's also O(n). Thus, n is the size of the input array, because just in case there is no duplicate elements, so we have to store each distinct element in our hash map once. Okay, so that's the extra memory. Both when we talk about complexity, both in terms of time and space, we talk about the worst case scenario. So if I hope this video is helpful to make sense of this problem. If that's the case, please do me a favor and hit the like button and also subscribe to my channel. Leave me any comments and feedback. I really appreciate it. Thank you so much. I'll see you guys in the next one.